Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I decided to start solving an AP exam of Calculus BC. And the reason is we are now in April, we are approaching the end of the year, and many students are preparing for that. So instead of going over each section and try to do many sessions, I thought maybe we can jump into exams and get the gist of it. I picked one from online. However, I didn't like some of the questions. I think there were typos. I don't know. It doesn't seem to be an official test. But anyway, I'm going to start with section one today, the multiple choice without calculators. We have 28 problems in 55 minutes, meaning you have barely 2 minutes per problem. Of course, you need to work fast, but at the same time to be very careful not to commit like foolish errors and lose points. So I will start with 10 problems out of the 28 or 10 questions because I don't want the sessions to be very long. So probably I'll break them into 10, 10 and 8 or 10, 9 and 9. Well, we'll see. So the first section, as we said, it's 28 questions, 55 minutes. I don't know, I enlarged it so you can see it. I don't know if it's clear on the screen or not. I'm going to read it anyway. So let's start with question number one. Question number one is a limit question. It says limit as x approaches 3 of x squared minus x minus 6 over x squared minus 5x plus 6. Of course, here you see that you have to factor, so you have to be good at factoring. We'd say limit as x approaches 3. The numerator, you have two numbers that multiply to negative 6 and add up to negative 1. So it's x minus 3 times x plus 2. The denominator, you need two numbers to multiply by 6 and add up to negative 5. So definitely they are negative 3 and negative 2. Now, since x doesn't equal 3 but approaches 3, I can simplify x minus 3 and x minus 3. Notice that once you write this, you know the answer right away. So we are not solving. That's why it's going to take me longer than it should take you, right? So if x is 3, then 3 plus 2 is 5. And if x is 3, 3 minus 2 is 1. So the answer is 5, which is D. That's number one. Quick. Number two, again, a limit, another limit problem. But now x approaches 0 of secant x over cosecant x. Well, not many, but some students, unfortunately, when they see one of either the numerator or the denominator cosecant x here is the reciprocal of the cosine, right? So, I'm sorry, the reciprocal of the sine. So it's 1 over sine, right? I can rewrite that as the limit. Or if you know already, if you know that secant 0 is 1, I'm sorry, yeah, secant, so in other words, what I mean is I can write this as 1 over cosine of x and the cosecant as 1 over sine of x. I know that sine 0 is 0, right? And cosine 0 is 1, so 0 over 1 equals 0. Don't say I'm going to take L'Hopital. L'Hopital works only if both the numerator and the denominator are zeros or are infinity, okay? But this is 0, yeah, A. So they give you two easy questions in the beginning. Let's move to number 3. Here we have 3 problems, 3, 4, and 5. Okay, the third problem maybe number 3. They want you to find ddx of 2x plus 3 over x minus 4 squared. We know that when you take the derivative of a quotient, you get the denominator square, which is x minus 4 square, meaning to the 4. And then you take the denominator times the derivative of the numerator, which is just 2, minus the numerator times the derivative of the denominator, which is 2 times x minus 4 times 1, right? So you can see that I can simplify one of the x minus 4, and the square. So the numerator would be 2x minus 4x, so negative 2x, negative 8 minus 6, minus 6 is negative 14 over x minus 4 cubed. Negative 2x, no, it should be over q. Yeah, so it's b, right? Negative 2x minus 14 over x minus 4 cubed. Notice that they give you the same numerator, but over x minus 4 to the 4. So if you forget to simplify, so that's basically b. Okay, so far so good. We don't have tough problems. Let's see number 4. Number 4, again, it's a limit as x approaches 0 of 2 sine 3x over 3 sine 2x. You should know that since we are not showing answer, you should know that the limit of sine of ax over sine of bx is a over b. And you say, well, how do I know that? Well, okay. If you substitute x equals 0, you get 0 over 0, right? So you would use L'Hopital. Don't do that in the test. You are wasting time. I'm just showing you why what I'm telling you is correct. If I apply L'Hopital, notice that the 2/3 is a constant, and I say limit as x approaches 0 of the derivative of sine 3x is 3 cos 3x. And the derivative of sine of 2x is 2 cos 2x. When you substitute x equals 0, cosine 0 is 1. So this guy would be 1, this guy would be 1, and you have 2/3 times 3/2. Did you see why the limit of sine of ax over sine bx is a over b, or 3 over 2 in this case? 2/3 times 3/2 is 1, and 1 is c. Okay. Unfortunately, I didn't. I thought it would take much longer than, we don't know the next problems, but I didn't want it to be a long session, and I didn't print out the next problems, unfortunately. Oh, it's not working. Let me do number 5. What types of discontinuities does the function f of x equals x squared minus 7x minus 18 over x squared minus 12x plus 27 have? We know that in order to find the discontinuities, we need to see, first of all, I have to factor both numerator and denominator. Why? Because if I get the same factor, it means I have a whole. But if I don't, I will see what would make the denominator 0, for example. Here we won't get a jump discontinuity, right? It's only one function, and both the numerator and the denominators are like polynomials, so you won't have that, right? So I can just ignore the jump or jump and removable. Okay, so this would be, of course, that's f of x. So f of x, I can write it as, you see here, negative 9 times positive 2 will give me negative 7 and negative 18, negative 7x, I mean. And of course, 27 is 9 times 3, so x minus 9, x minus 3. This is a whole right there. X minus 9, x minus 9. So there is a whole at x equals 9. Also, at x equals 3, I have an asymptote, a vertical asymptote, meaning that's essential, right? Or infinity, meaning an essential. So essential and removable, because it's a whole, is E. So infinity, another word for that is essential, and removable is another word for whole, right? If you remove the whole, you won't have any discontinuities. Okay, so these are 5. Well, yeah, we took roughly 2 minutes in each, but again, because with explanation, if you are just solving, it shouldn't take you that long. Alrighty, so number 6. Find the fourth derivative of f of x equals x to the 4 minus 4x cubed plus 3x squared minus 4x. And you say, oh my God, I will take 4 derivatives. And each time I will use the quotient rule. Nope, you won't. Why? Because you have to simplify. You can say x to the 4 over x cubed is x. Negative 4x cubed over x cubed is negative 4. And this guy is 3 over x. And this guy is negative 4 over x squared. I have to ignore these two guys because the first derivative, I will get 0 here. The second derivative, this would be 0. So I really, as if this problem was like that. Let's find the first derivative. This is x to the negative 1. So when you take the derivative, you get negative 1 x to the negative 2. So it becomes negative 3 over x squared. This one is 4 x to the negative 2. When you take the derivative, it becomes negative 2 times negative 4 is positive 8 over x cubed. So you see, every time you just change the sign from positive to negative, positive becomes negative, then positive, then negative, and negative would be positive. And all what you do is you multiply really the 3 by the power of x. It was negative 1. That's why 3 times negative 1 is negative 3. And negative 4 times negative 2 is positive 8. So the next time, I don't waste time. This would be negative 3 times 2 is negative 6 over x cubed. That's the fastest way you do it. And 8 times negative 3 is negative 24 over x to the 4. Then the next one will be f to the third one would be negative 6 times negative 3 is positive 18 over x to the 4. And negative times negative is positive. 24 times 4 is 96 over x to the 5th. Yeah, I thought they would give you one of those as one of the answers, but no. Okay, f4 of x. 18 times negative 4 is negative 72 over x to the 5th. And 96 times negative 5. Notice when you multiply by 5, it's with an even number, it's easy. You divide by 2 and add a 0, right? Because dividing by 5 is multiplying by 10 and dividing by 2. So half of 96 is 48. So that would be 480 over x to the 6. You see the last, that's the error I wanted to say. That should be 72x, not 7x. That's one of the errors I found. That should be 72x minus, because when you take, no, and in fact it should be, wait a second. Oh, This was positive, this was negative, this was positive. So when you take a common denominator of x to the 6, that would be 72x minus 480. It is e, but they wrote it 7x, unfortunately. So we have to correct that, and that's e. That's why I said it couldn't be an official test. Let's move to number 7. d dx of secant 5x over 5. Notice that the 5 is a constant, so you can take it out as 1/5. And then the derivative of secant, first of all, is secant tan. So you get secant 5x tan 5x. Notice the chain rule. Then once after you take the derivative of the secant, as secant tan, you go inside and you see 5x, and the derivative of that is 5. So the 5 and the 5 cancel, and you get secant 5x tan 5x, which is d. And sure enough, they give you the 5 here to trick you if you forget the 1/5. I should have taken more than 10. I'm sorry. It's the first time I do it, so I thought it would take longer. We are still working. What is the volume of the solid formed by rotating the region between the curve 6x, y equals 6x squared minus x, and y equals x squared minus 6x? Okay. So both graphs about the y-axis. Okay. This one, both of them pass through the origin, right? This one has axis of symmetry at 3. So it has to go something like that. This is x squared minus 6x. And because when you substitute x equals 3, you get 9 minus 18. So this is negative 9. It really, that's not important for now. And then the other one is very close to the 0, the axis of symmetry, right? This would be, wow, this is, so 0, if x is 0, y is 0, and this is even, it's 1/12, so it's going to be very, where are they going to intersect? At 0, 0, I didn't draw it correctly, but then you would say 6x squared minus x equals x squared minus 6x, right? So you can solve for the other point of intersection, which should be probably at 1, right? Because this would be 5 and 5. When you move this, you will get 5x squared equals negative 5x. So either, so x equals negative 1 or x equals 0. So at negative 1, so really these two would, okay, maybe one of them would look like that. So at -1 and 7, right? Yeah, -1 and 7 and 0 and 0. These are the 2 points of intersection. And you want to take this guy and rotate it about the y-axis. So really it's going to be this distance x or -x, since you are -x, times 2 pi times that height, which is so it's the integral from -1 to 0 of 2 pi. In fact, there is a negative also, x times this minus that, and we already did these, so it would be 5x squared plus 5x dx, right? When I move these, 6x squared minus x squared is 5x squared, and -x plus 6x is plus 5x. So -2 pi, the integral from -1. In fact, I can take the 5 out, and this would be -10 pi times x cubed plus x squared dx equals -10 pi x to the 4 over 4 plus x cubed over 3 evaluated from -1 to 0 equals -10 pi times 0 when you substitute with 0, so don't waste time. And then when you substitute with -1, -1 to the 4 is +1, and -1 cube is -1. So 1/4 minus 1/3, which is -1/12, right? You take the common denominator of 12, you will get 3 minus 4. So this is basically, in fact, we don't care about the negative sign. In fact, that's a volume, so that's basically 10 pi times 1 over 12. 10 over 12 is 5 over 6. It's 5 pi over 6, which is E. Okay, yeah, that would take some time to, since we don't have a calculator, we cannot plot it. If we move to the next one, number 9. Number 9, they want you to integrate x cubed natural log of 2x dx. Basically, when you have something like that, you can use the tabular form where you pick, instead of doing it the long way. So I can say this is what I'm going to take the derivative of, and that's what I integrate. I don't know how to integrate natural log of 2x. Well, I do, but generally speaking, we don't know. So I'm going to use this because its derivative is easy. And I'm going to integrate the x cubed. When I take the derivative of natural log of 2x, it's 1 over 2x times the derivative of 2x, which is 2. So you'll get 1 over x, right? It's 1 over 2x times 2. You can write it and then substitute. This is x to the 4 over 4. And then what we told you when we use the tabular form, we say positive. Notice that if I keep going, I will get -1 over x squared and x cubed over 5, and I will never end. So you stop here and you say, this is positive and this is negative. That's how we do it. So the answer would be x to the 4 times natural log of 2x over 4 minus the integral of x cubed over 4 dx, right? Because when you multiply, you get x cubed over 4. equals x to the 4 natural log of 2x over 4 minus x to the 4 over 4 times 4 over 16 plus a constant. Well, you can see that if you take x to the 4 over 16 as a common denominator, of course, you won't do that. That's a waste of time. X over 4, and this is over 16, so that you have to multiply that by 4 because 4 over 16 is 1 over 4, natural log of 2x. And when you take this whole thing, you get minus 1 plus a constant, which is also, no, which is C. No, it's A. X to the 4, you see they are very similar. X to the 4 over 16, 4 natural log of x, 2x minus 1 plus a constant. So that's A. And finally, the last one, number 10. Oh, I think this one has a typo also. This turned out to be negative, not positive. Integrate x minus 10 over 2x squared minus 5x minus 3 dx. It's not plus 10, it's minus 10. Definitely, I will use partial fractions, right? So this can be written as the integral of x minus 10 over. And now when you factor out these, you have 2x in one and x in the other. In fact, you can see one of them is x plus 3 and the other is 2x minus 1 from the answers. But it's not that hard. You multiply 2 by negative 3 to get negative 6, and then you add x to make it negative 5. So we know that. Now I'm going to say x minus 10 over, oh my God, over 2x plus 1 times x minus 3 equals a over 2x plus 1 plus b over x minus 3. You can take a common denominator and do this and do that, but it's usually easier if you learn when you have only linear denominators, 2x plus 1, x minus 3. Let's start with x minus 3 because it's easier. You can say, what makes the denominator 0? It's x equals 3, right? So you hide the x minus 3 and substitute x equals 3 in the rest. So you get 3 minus 10 is negative 7. And 2 times 3 is 6 plus 1 is 7. Negative 7 over 7 is negative 1. So b is negative 1. You can do the same thing. You say what makes the denominator 0 is if x is negative 1/2. So you hide this and you say x is negative 1/2. 1/2 minus 10 is negative 9.5. Negative 1/2 minus 3 is negative 3. No, wait a second. Negative 1/2 minus 10 is negative 10.5. And negative 1/2 minus 3 is negative 3.5. When you divide this by that, you get 3. So a equals 3. So really, now I'm going to integrate 3 over 2x plus 1 plus or minus 1 over x minus 3 dx. Notice this is 2x, not x, right? So what do? I want the numerator. If the derivative of 2x plus 1 is 2, I have 3, not 2. So what do I do? If I want the 3 to be 2, I'm going to say 2 times 3/2. So this becomes 3/2 natural log of 2x plus 1 minus the derivative of the denominator is 1. So it's natural log of x minus 3 plus a constant. 3/2 natural log of 2x minus, no. Wait. That's another error. I didn't notice that because I wasn't solving. That should be minus this. Oh, it's 2x plus 1 and x minus 3, not the other way around. So I think, oh, maybe the problem was x plus 10 over 2x squared plus 5x minus 3. Oh my God, this is completely wrong. I'm sorry. I didn't, I thought the error was that this should be minus 10. In fact, I think we can do that next time. Or you can do it and find out what do you think the correct problem is. It's weird. We found like 3 errors in the first 10 questions. I'm so sorry about that, but I really, that's what I found and I copied it exactly as it was. So if that was 2x squared plus, so that would have been 2x and x, and this would be minus 1, and that would be plus 3. Yes. So maybe that was x plus 10 then. So the error was at the denominator, not the numerator. If we say x equals negative 3, no, let's see, x minus 10. If it were like that, I would say a over 2x minus 1 plus b over x plus 3. I would substitute x equals negative 3. No, so that was plus 10. Yeah, this was correct. That was plus 10, but this was plus 5. Oh my God. So they switched it. Okay, in this case, when you say x equals negative 3, you get negative 3 plus 10 is positive 7. And negative 6 minus 1 is negative 7. So again, b is negative 1. But then you would substitute x equals 1 half. This would be 10 and a half. Yeah, and a would be 3. So you will get 3 halves, the natural log of 2x minus 1 minus natural log of x plus 3 plus a constant. And that is the last one, e. But the problem was integral of x plus 10, as they wrote it correctly, over 2x squared plus, not minus, 5x minus 3 dx. And this is the answer. I hope that wasn't that bad. I know there were errors, but as you can see, the first part, at least the first 10 questions, maybe the one with the finding the volume and making a disk and rotate it will take some time, but the rest of the problems are really shouldn't be that bad. You can see that many of them are just a single one-liner, like the first 3 and then number 7. This one is a little tricky because we have natural log of 2x, and usually when you have that, when you have natural log, you make it the one that is where you take the derivative, and the other one would be integrated. And again, if you have any questions, please let me know. I will try to solve or pre-solve the next 9 problems to make sure they don't contain any other errors, because I really didn't expect that until very recently, right before I started the session. Anyway, I hope you benefited from that. If you have any questions or you found something that didn't make sense to you, please don't hesitate to let me know, and I will try to get back to you as soon as I can. Thank you very much for your time. Have a great day. See you soon.